Hey guys, welcome to section 5, chapter 10 of the geometry program. In the last two sections, we were working on finding surface area, and in the next two, we're going to work on finding the volume of the same three-dimensional shapes. Volume actually, I think, is a little bit easier than surface areas, so we should be able to cruise through this pretty quickly. So the first formula that we need is for the volume of a prism, and that's going to be given by V equals capital B times H. And we already know what capital B stands for. It's the area of the base. And then of course, H is the height. So you can see it in our picture here. Very similar to working with surface area. So without further ado, let's jump into an example. All right, here we have a square prism, and we know it's a square because the base has the same sides on all sides. So if we use our formula, big B times H, the first thing that we have to do is find the area of this base. So I've highlighted it for you here, but if I pull it out to the side, I know it's 5 and 5, and the area of a square base is the side squared, so 5 squared, which is 25. So this is 25, and then of course the height is here at 6th. So the volume is going to be 225 feet cubed. Now notice this difference. When we were dealing with surface area, everything was in squared units. But now we're dealing with 3 dimensions, and so our units are going to be cubics. So make sure that you change that little superscript to 3 and not 2. All right, let's go ahead and move on to another example. Here we have a rectangular prism. Rectangular because our bases are rectangles. All right, so the volume is going to be the area of the base times the height. Now I'm going to show you 2 versions of this because you might see the bases differently depending on the rotation of this prism. So if you kind of keep consistently with the way that I have been drawing them, then you would recognize my base here is the rectangle with sides 5 and 8. And we could find the area of that by multiplying width times length, which would give me 40. So we could go ahead then and start volume equals the area of the base, which is 40, and then times the height, which is 6. When you multiply that together, you're going to get 240 inches cubed. Now, there's a chance that you might see it rotated differently. Again, depending on the orientation of the shape. You might see it as 8 and 6 and 5. Okay, in that case, again, as long as we stay consistent with our formula, then now my base is 8 and 6, giving me the area of 48, but that's okay because multiplication is commutative. If we put in the area of 48 here and now use our height of 5, when you multiply that out, you'll still get 240 inches cubed. So it's okay if some of these are transposed a little bit and you struggle to identify which is the base, as long as you consistently find the area of that base and multiply it times the height, which it should be askew from that, then you should be fine. Okay, let's do one more where our base now is a triangle. So you can see our triangle here. And I'm going to pull it out so we can see it better. It's got hypotenuse 10. It has a side of 8. And then this side is congruent to that side. So it also has to be 6 here. And I could find the area of this triangle by taking 1/2 the base times the height. So the area of the triangle is 1/2 8 times 6, which is going to be 24 kilometers squared. Okay, now for our volume, we have the area of the base times the height. We just found the area of this base, which is 24. And then again, look at the height. The height is always going in the opposite direction. So that helps us keep our numbers correct. And when I multiply that together, I'm going to get 168 kilometers cubed. All right, so hopefully you find this a little bit easier than the surface area, a little bit less to work with here. Just have to identify what your base is, and again, finding that area, and then identifying the height correctly. All right, the other shape that we work on in this section are cylinders. And cylinders, I think, are even easier because the base is always a circle. So we can use the same generic formula for the area of the base times the height, or you can recognize, since the base is always a circle, that it's always going to be pi r squared to find the area of the base, and then times the height. All right, so if we jump in here and we use the volume is equal to pi r squared h, then I can identify my radius. Down here is 5. We got to square that. And then multiply times my height, which is 11. And you're going to get 275 pi kilometers cubed. Or if you want to convert it to a decimal, it could be 863.5 kilometers cubed. Either one, I like it in terms of pi, but it makes it challenging to check to see if your answer is correct. So feel free to plug that in if you need to, but also leaving it in terms of pi would be good. All right, last one, and this one's just a little bit offset. That's why I wanted to do this example for you. So we use our volume formula, pi r squared h. This time we're given the diameter, so we need to be mindful of that. We need only half of that for our radius. So half of 6 is 3. And then, of course, our height here is also 3. So remember, the height is going to be measured from the top to the base. And then when we multiply this together, we're going to get 27 pi inches cubed. Or again, if you want to convert that, 84.82 inches cubed. So either one is fine. All right, that's it for this section. Hopefully it's pretty straightforward for you. Finish up your notes, read through the examples, and begin your assignment.